Hello, welcome once again to Radical Academy, and in this video we'll be looking at tangents and normals. So what we mean by that, we'll be looking at still calculus, and we want to see how you can be able to apply differentiation as in terms of calculus. So this is what we have been doing about differentiating functions, or rather differentiating polynomials of higher degrees. So we have actually done product rule, chain rule, as well as quotient rule. And I want to say that for us to begin out to understand how we can apply those concepts of differentiation, we must be able to be comfortable with such methods of differentiation. So remember, for those that are watching for the first time, remember to support me by liking, subscribing, as well as following my Facebook page for more of these videos. So without much further ado, let us now jump into this video about the tangent as well as the normal. So we have to now understand what is a tangent and what is a normal, so that we can now begin to integrate whatever that we have learned in terms of differentiation. So let's do this. So what you have now is that we'll be looking at equations in terms of tangents and normal to the curve. So our very first example is talking about find the equations. Okay, so find the equations of the tangent. So the equation of the tangent and the normal to the curve. So by this we begin to understand what is the normal. Okay. So the normal as well as the tangent. Okay. So these are the two key concepts that we must be able to understand. Looking at the normal as well as the tangent. So the normal is simply just a line, okay, that touches, that we can draw, okay, to the curve at any point, at any given point. In this case, we have this point 1, 2, okay. Now, so that is basically the normal is simply the line that is going to form what is called a perpendicular, okay. So the curve, okay, and the normal. And now what you need to understand, the normal is a line that is somehow forming just the tangent, okay, because this normal is touching the curve at the specified point. Now, what you need to understand is when you are being given this kind of an equation and it passes through at this point, okay, the first thing that you must be able to do is to differentiate. Okay, so to differentiate this function, or rather the equation. So first of all, y is equal to x to the power 2 plus 4x minus 3. So now we have learned about differentiation. Okay, so we're just going to use the simple and normal rule. Okay. So what is going to happen is I'm going to say dy dx is equal to 2x plus 4. Okay. Now this is what we have. Now once you obtain this, this is what we call the gradient function. Okay. So this is what we call the gradient function. So every time you differentiate an equation, okay, or a function, the final answer is actually referred to as the gradient function. Okay. So the gradient of that function, okay, has actually got a specific point. Okay. If I want to talk about the gradient, the gradient function at some point, I need to have a value of that point in terms of the x-axis. So what we mean is that we have been told that finding the equation of the tangent and the normal to the curve, okay, at this point. Okay. So now you can now say dy dx, because this is what we know, equals to m, and m now stands for gradient. is equal to 2x plus 4. Now, what we're just saying here is that the dy dx is simply the gradient function at a particular point. Okay, so meaning that the dy dx can be written as an equivalent to as a m variable in terms of the gradient, because we know from the standard principle that the equation, the gradient representing the gradient of a straight line is as a mathematical symbol, or rather the variable as m. That's what we know. So we can now say m equals to this gradient function, or rather the differential function. So from there, now this is going to be gradient. Okay, now we know that x equals to 1, okay, because this x, this point at which this curve is passing is at this point. So what you're simply saying is that what is the gradient at this point? X equals 1. So x equals 1, we just replace, okay, and this is going to give us m is equal to 2 plus 4, and this will become 6. Okay? Now, once we find the specified gradient, because when x is 1, the gradient of that differentiated function, or rather equation, is 6. So, the gradient of this curve, okay, and the normal, okay, is, I mean, the gradient of that curve and the tangent, they're just the same, okay. Okay, so I was just trying to recopy that. So from there now, the gradient of the tangent to the curve at 1, 2 is 6. So we have this gradient as being 6. And then from there now, which is the same as the gradient of the curve. Okay, so this gradient, okay, of this curve and the tangent, they're just the same thing. Okay, so then the equation to the tangent, okay, so now because the gradient of the curve, okay, and to that of the tangent, this is the same thing. So if we find that the gradient function of that curve is actually at 6, so that gradient is also for the tangent, okay? That is what you need to understand. At that point, x equals to 1. That is a tangent point. So from there now, we can find now the equation of the tangent, okay? So the equation of the tangent, we know that gradient equals to y, okay? What I can do is I can simply say y minus y1 over x minus x1, okay? Now, I know that the tangent point is 1, 2, okay? So this is x1, this is y1, okay? Okay, so the gradient, the tangent point is 1, 2, and this one define x1, this two define y1. Now, I also know that the gradient is 6, so this becomes 6 equals to y minus 2 divided by x minus 1. And then now I can just make y the subjective formula, okay? So this, and then now I can say cross multiply. So 6 open bracket x minus 1 equals to y, and then y minus this. Okay. So now we can expand the bracket. This is 6x minus 6 equals to y minus 2. Okay. Now we make y the subject. So this is going to be 6x minus 6 plus 2 equals y. And then from there we know that this is the like term. So 6x minus 4 equals y. So therefore, y equals to 6x minus 4. Okay. Now, this is what you need to understand. So, the equation of the tangent, okay, at that point, either x equal 1 or just that full coordinate point 1, 2. So, we have come to understand that the tangent is actually the equation as y equals to 6 minus 4. Now, we can find also the equation to the normal. Okay. Now, I want you to understand one thing. That the tangent, okay, the tangent and the normal are just perpendicular to So this is the most important concept that you have to understand. So the most important concept that you have to understand is that the tangent and the normal, okay, are just perpendicular to each other, okay. And that's what you need to know. Now, because the tangent as well as the normal, okay, they become perpendicular, so they become like this. So meaning this and this, the horizontal and the vertical, they actually give us some concept to say the gradient of this and the gradient of that will actually equal to -1. Okay. So now what you're supposed to find now is the gradient of the normal. Okay. Because the gradient of the tangent has been found to be m equals 6. So we are going to find now the gradient of the normal. Yeah. Okay, so now what we have is that this is for the tangent. Okay, this is a tangent. Okay, and its gradient is equal to 6. Now, when you look at this equation, okay, as long as you have made y the substitute formula, okay, when you look at this equation, as long as you have made y the substitute formula, you can just, by observation, once you look at this equation, okay, y equals to 6x minus 4. Now, the coefficient of x is the gradient of that equation to the tangent. So, if the gradient of the tangent is 6, then we expect the gradient of the normal to be -1/60, okay, or rather -1/6. So, of course, let's see how that is coming up. So, we know that since the tangent and the normal, they are perpendicular, so m1 multiplied by m2 equals to -1. So we know that now we know that m2 is normal. So now, and m1 equals to 6. Okay. So from there we can substitute 6 multiplied by m2 equals this. And this is going to be 6 by 6, and this goes. So our m2, which is a gradient normal, okay, Now, because our gradient of the normal is negative 1, 6, so now we can now find the equation of this normal. Now, because they are passing through the same point, that's where they are making the perpendicular to each other. So we're going to actually use the same thing. 1, 2, those are still the points that are both sharing. Okay. So then, equation for the normal, okay? So equation of normal, okay? Now this has got, we know that the gradient, which is m2, is negative 1 over 6, okay? And the coordinate, which is just the point, is 1, 2. So therefore, we can say m equals to y minus y1 divided by x minus x1. So then we know that m is this one. So negative 1 over 6 equals to y minus y1, okay? We know that this is y1 and this is x1. So we are going to have this over x minus 1. Okay. Now, once I have these points now, I have this now expression, then I can just evaluate, or rather just simplify it, so that I can have something in form of a linear horizontal. Okay. So now, then, negative 1 over 6 so you can cross multiply now. So negative 1 okay. So make sure that when you are trying to cross multiply, you show what is actually multiplying each of the brackets, so that you're just able to see where you're going at. Okay. So this times this. Okay. So from there now you can say, you can just reverse this. Okay. So I've just actually reversed, but I've not actually made any of the variable term to cross over. So this is going to be 6y. 6y is equal to negative x plus 1 plus 12. And this is 6y equals to negative x plus 18. Okay? Of course, you can make y the subject. So you divide both sides by 6. So y is equal to so now this is now the answer, okay? This is now the answer. This is the final equation to the normal. So this is how you can be able to apply differentiation. So you saw at the first instant we had to differentiate that that equation y equals to x squared minus this plus that was just x to the power something. Okay, so we had to actually differentiate this, and then from that we had to find the gradient function and find the specific function at x equals to 1, and then from there, since they're sharing the single point 1, 2, so we use that both for the equation to the tangent and equation to the normal. Now, because the equation to the tangent and the normal, they form perpendicular, so the product of these two gradients equals to -1, and that's what we actually use to find the gradient of the normal by making m2, which is the gradient to the normal, the substitute formula, and then from there we had to use the single point at which the tangent is forming 1, 2, and then from there we had to use the equation of the finding the gradient, okay, which we actually saw, and then everything came down to this. So this is how you can apply. So thank you so much for watching. Remember to support me, subscribe to the channel, like, as well as follow this Facebook page. So thank you so much for watching, and I'll see you in the second, probably some of the other videos about the same, so that we can actually get the concept. It's bye-bye, and I'll see you in the next video.